Okay, this is the first lecture in statistics, and we'll introduce you to some very important concepts. First, you have a population. That's the universe. So if you're looking at Americans and, let's say, income, the population might consist of everyone who lives in the United States, 310 million people approximately. If you take a census, you've actually surveyed every single person, all 310 million people. That's very costly. Statisticians do not try to do that usually because of the expense involved. You imagine trying to survey 310 million people. So normally we don't work with the population, we work with a sample, a subset of the population. And it better be a representative subset. And that's why we have a whole field of sampling and how to get a representative subset. Some of you may have heard the term simple random sample. It's in the notes, and it describes one way of getting a representative subset of the population. So in this course, whenever we talk about a sample, the assumption is that the sample is representative. Once you have a biased sample, if it doesn't represent the population, you got garbage. So we're always going to assume that the sample was representative. That's a simple random sample, and it represents the population. Now you're going to be very surprised when you find out that most of the time in the business world, when they take a sample, they're talking about sampling, you want to know what Americans are watching. You don't go to almost 110 million television households to see what they're watching. The Nielsen company works with a sample of about 5,000. Gallup, and they want to find out who you're going to vote for, they don't go to every single voter. They work with about 2,000. 2,000 voters. And that's sufficient to get a very good idea as to who's going to win the election. Now the measurement that comes out of a population census, if you do take a census, the measurement is called a parameter. So when we talk about a census, we're talking about the population mean, the population standard deviation, the population median. These are parameters. Parameters come out of a census. So again, if you survey the entire population, that's called a census. Any measurement you obtain from that is called a parameter. So population mean is a parameter. Population standard deviation, it's a parameter. But rarely is this done. Almost always we find that we're working with samples. Again, a sample is a subset of the population, and it has to be representative. Right? This course assumes that you took a good sample, it's representative. Well, any measurement that comes out of a sample is called a statistic. So we have a sample mean, a sample standard deviation, a sample median. All right? So measures that come out of a sample are called statistics. Measurements that come from a census, we basically work with the entire population, those are called parameters. This course is called statistics because we rarely take a census, very rarely. Too costly. So we almost always work with a sample. Let's say a company like, let's say General Electric wants to know what is the average life of their refrigerators. And let's say they make 3 billion refrigerators a year. They will take a sample of them, maybe 300. Test those 300, and based on that, get an estimate of the average life. But since they took a sample of 300 out of 3 million, we call that a sample. Again, the techniques to make sure the sample is representative. Alright, but any measure they get is called a sample. They'll get the sample mean. Alright, now how do you go from a sample to a parameter? Now the thing to remember is, let's talk about the mean. If you took a census, there's only one true mean. That's the population mean. There's only one of them. There's one population mean. That means if everyone in this room took a census, we'd all get the same population mean. There's only one of them. And that's why it's called the true mean. On the other hand, if every one of us took a sample of, let's say, 1,000 people out of 310 million Americans, and we want to know the income, we might find we all get slightly different numbers. And that's a very important idea in statistics, that there's only one true population mean. There's only one of them. When it comes to a sample mean, there are millions and millions of them, actually infinite number of them. Any one of us, you can take a sample of 1,000 and get one sample mean. I can take a different sample of 1,000 or 2,000, it doesn't matter. I'll get a number that's slightly different. Sample means are used to estimate the population mean. And that's a whole field in itself, which we're going to learn in the second half of the course, called statistical inference. How to use the information we get from a sample to make an inference, to infer something about the population. We want to use the sample mean to infer something about the population mean. Remember, there's only one population mean. There are a lot of sample means. We're going to talk about the sampling distribution. If every one of us took a sample mean and we plotted it, that's the sampling distribution of the mean. And we'd find out something very interesting. We'll learn about this again in the second half of the course. If we all take a reasonably large sample size, and we wrote down our x bar, the sample mean, we plotted it, it would follow a normal distribution around the true mean. And that's you know about the normal distribution, but we're going to learn about it in the second half of the course. Normal distribution is something called that bell-shaped curve that's so famous. But again, the key point is there's only one population mean. Only one. However, there are many, many, many sample means. And the sample means are used to make an inference, to infer about the population mean. Okay, so that's how that's the most important concept. So make sure you know the difference between a parameter and a statistic, and the population and a sample. Okay, good luck. Bye.